Okay, today we're talking about polynomial operations. First, the word polynomial. First, let's kind of take it apart. Poly, meaning many or several. Nomial, referring to the terms that contain different powers or different degrees of a variable. For example, if we had something like this, 2x squared plus 3x plus 5. Okay, we have three terms here. Okay, 1, 2, 3. We said terms are separated by addition or subtract. Adding a negative would be subtraction. Okay, within each term we have factors, right? But each term has of course, the whole thing is in descending order of the degree of each term. Okay, by the way, what's this one? This is a 1, right? Notice the last one, the constant term, will also be a degree of x, right? But we'll say it's x to the 0 power. This is why we teach you guys in the exponent rules that anything we raise to the 0 power is 1. So essentially, what we do not do is picture x to the 0 power. Usually you don't see that one. Okay? So keep that in mind. We have our three special ones, or really the names kind of just change a little bit. Monomial is 1 term, binomial 2 terms, trinomials are 3 terms, like in the example here. This would be a trinomial. And so anything beyond 3, 4, 5, 6, and so on, those are just plain old polynomials. Okay, let's have some problems. Let's take a look at some of the skills you're going to have to master for your test. Okay, so we want to perform the indicated operations. We're going to start with addition and subtraction. So this first problem, A, and then we'll state the degree of the resulting polynomial. If we look at A, what's going on here is we have addition between two polynomials. That's the indicated operation, okay? Okay, so when you have addition to start, basically you just begin by combining the like terms, okay? So the x cubed term didn't have anything to combine with, so it just kind of got brought over. Of course, then we have a positive x squared term. Positive 5x didn't have anybody to combine with, but the negative 3 and the minus 8 do combine to make a subtraction of 11 on the end. Now the degree of this term would be the highest exponent on x. Note that the answer I give is in the descending order of the x terms, degrees. The exponents should be I guess displaying a countdown of sorts. So the highest exponent should be first. And that would also give you the degree. So the degree of this polynomial would be 3, or the third degree. So this is a third degree polynomial. Okay? Okay, so now let's look at part B. Notice B begins with the indicated operation of subtraction. So when you have subtraction between two polynomials, what you start by doing is taking the opposite of each term of the polynomial that's being subtracted, okay? Now in the parentheses we have a positive 2x squared, right? So what we're going to do is we're going to bring down this 4x squared, okay, and plus x plus 7, okay, the first polynomial. And once we take the opposite, or we can also say we're distributing the negative, it will become a plus, right? It will become an addition problem. It'll be adding the opposite of the polynomial in the parentheses. So it becomes a negative 2x squared in parentheses, a minus 3x, and plus 2. So I've taken the opposite of each term in the parentheses, and it has become now an addition problem. So now our task is to combine the like terms. So what we've done is we've distributed the negative, or take the opposite of each term. All the terms have to go opposite sign, right? Take the opposite sign. So now we're just going to combine like terms. And once you, let me tell you this too, once you distribute that negative, you really don't need those parentheses. If it's just the addition, like the first problem, you can disregard the parentheses and you don't even really need to write them. So let me kind of show you this little trick here. We can disregard the parentheses once you distribute. Just keep track of those signs. This is going to be still minus 2x squared, or subtract. It's a negative. So when we combine it with the 4x squared, we do need to have 4 minus 2 in mind. So let's kind of write that result now. Okay, let me scroll down a little bit. So we'll have, let's go down a step, 4x squared minus 2x squared. So 4 minus 2, and that'll make us 2x squared for our first term. Let's look for x's. So we have a positive, and we can put a 1 if you need it, if it helps. Negative 3 plus 1. So we'll have negative 2x. Then we have 7 plus 2 plus 9. And this is a what? Second degree, right? Second degree polynomial. Okay? The degree is 2, or we say is second. Okay? Because of the 2 being the highest exponent, it's a second degree. By the way, the second degree polynomials will have a special name as well in the future. Second degrees are also going to be called quadratic polynomials. Okay? Alright, so let's kind of go on to multiplication and division. Let's take a look at that. Alright. Okay, so let me give the fair warning. Fair warning is this. Multiplication and division of polynomials will require the knowledge and use of your exponent rules and your distributive property. So if you need to go back and practice the exponent rules, it might be a wise thing. We do that in this section anyway when we take a look at the negative exponents. So there'll be examples of that in a bit. But first, let's continue with our polynomial operations. Okay, so if we look at C there, I've already begun. We have 4x cubed plus 9x to the 5th. Of course, we want to go ahead and multiply 4 and 9. That gives us a 36. And then x times x cubed times x to the 5th. Remember, when you multiply exponential forms straight across, what happens is we add the exponents. So that's why I have this second step in there. So that'll be x to the 8th power. 36x to the 8th. That's my answer. Now, starting with D is where we have now a monomial times a binomial. And this works the same pretty much for any monomial times any polynomial. We distribute and then always check to see if we can't combine some like terms. But 9 out of 10 you probably won't. But here we go. 3x squared, right? 3x times x. So it'll be 3x squared. Then x times negative 1 is just the opposite of x. And we're done. And we have negative 2x times 2x squared plus 3x minus 1. Be sure to distribute negative 2x thoroughly. If there are 3 terms inside the parentheses here, after you distribute your negative 2x, you should have 3 more terms outside of the parentheses. So here we'll have what? Negative 2 times 2? Negative 4. And now x to the 1st power times x squared is x cubed. Now negative 2 times 3, that's going to be minus 6. X to the 1st, x to the 1st. That's x squared. Negative 2x times negative 1 is just the opposite of negative 2x, or plus 2x. You want to go ahead and check your work. Make sure you've kind of looked at your exponents and added up the exponent correctly on the x. So that would be a good thing to do. Check your work. Now what we have in F here is binomial times a binomial. A lot of you have learned the FOIL method. But what I'm going to show you first, before I show you FOIL, is just the general way. And FOIL does this, but in a different order. So if you have a polynomial times a polynomial, so this, what I'm going to show you here, is going to work for everything. Okay, so what you're meant to do is to take the first term of the first polynomial and distribute it into the second polynomial. So we'll have 2x distributed into x plus y first. And then each term from here, the first polynomial, will be distributed into the second one, okay? So now we'll have plus y. You can see that separation, that first polynomial. We have this 2x plus y here, multiplied times x plus y. See, so that's how we set up a general polynomial times a polynomial. And we're going to do that in G in a minute. But let's finish this one up. So let's go ahead and distribute, then combine our like terms. So we have two separate distributions to do here. Okay, so first is 2x squared. Then we have 2xy. Okay, then we have plus xy. If xy is the order, the general term for me, I tell my students to put your exponents in alphabetical order. If there's more than one, variable is what I meant to say. If there's more than one variable, get them into alphabetical order to keep them, I guess, organized, so that when you go to combine your like terms, you won't fool yourself. So we have finally a y squared. So now this will be easier to spot, the combining of the like terms. So the answer to this one, 2x squared, we'll have plus 3xy, and then plus y squared. Now, this x squared, xy, and y squared term, when you have an x and a y term in a binomial, this is going to be the pattern of your variable and exponents, okay? You'll see these patterns start to arise. All right, let's try distributing and combining like terms for G. So first, let's set up each term from this first polynomial will be set up as distributed into this whole trinomial. So that's your first step. We take 2x and just simply just write it out. You don't even have to do the distribution, just set it up first. Do yourself a favor and keep it simple. One thing at a time. Let's set it up. Now minus 1. And go ahead and write the 1. No big deal. Let's do it. Keeps you organized. Keeps your problems with less error. That's a good thing. So now we've set the multiplication up and we can begin multiplying or distributing. So let's go for it. 2x cubed. What? Plus 6x squared. And you can pause the video. I'm going to fast forward through this. So notice when I went ahead and I distributed my -1, it's a similar thing to distributing the negative. I've taken the opposite of each term in the second little set of parentheses there. So I end up with a minus x squared minus 3x and a plus 5. Now we always have to check to see if we can combine some like terms, okay? Remember, we do want our answer to be in descending order, so pick your highest degree term first, and that would be the cube term. There's no other cube term, so we just bring it down. Now we do have an x squared term here and here, so 6 minus 1, right? It's going to be plus 5x squared. Okay, and then we have two x terms to deal with, so we'll have minus 13x. Okay, and then plus 5. And there's your answer. Okay. Good job. And the more you practice this, the simpler it gets. It really does get so much easier. As a lot of you are finding out, so I see in the post-lecture discussion, a lot of you are realizing that the time you put in practicing these is directly correlated to your grade. I mean, really, if you've struggled before, you may realize now that it does come to you and it does get easier when you practice more. Okay? Alright, so let's take a look at H and I. What we're looking at now would be some special forms, some special things that are going to start happening, especially when we square a binomial. Let's have a look at this. Okay, so we can FOIL it. If I were you, I would go ahead and write it out, the square, I mean. So we have x minus 3, we need to write it twice as multiplication. You can go ahead and FOIL, okay, first, outer, inner, last. It just gives you the order of multiplying these terms. It's like first is x squared, outer minus 3x, inner minus 3x, last plus 9. Now here's what the perfect square trinomial is. What happens is you have two of the same thing in the center. when you go to multiply them, when you're multiplying, you're building it up, okay? And so you'll have twice, so this becomes twice what? The root, right? Twice the 3 times the x, the root of the first one, the square root of the second one. So it'll be 2 of these, right? And it's going to be minus because it's subtraction. Okay, of course, x squared comes down plus 9. So essentially we have x squared minus 6x plus 9. Eventually, I'd like for you to realize that this is a perfect square trinomial. Do not get that confused with completing a square. That is not the same skill, by the way. Please remember this. Recognizing a perfect square trinomial is not the same as completing a square. Okay? Please do not make that mistake. Okay? Because in my class this semester, we're not really worried about completing the square. Okay? Not this time. Okay? So let me label this a perfect square trinomial. And you can read more about it when we get into factoring. The beauty of it is that you can recognize the perfect square trinomial and follow suit as far as your factoring goes. If you don't recognize it, it's not going to make a difference. If you've practiced factoring trinomials in general and you're getting good at it, this will still factor just like the other trinomials will. We'll cross that bridge when we come to it. Now let's look at I. What do we have here? I is very similar to H, it's just the exponent has changed, okay? So let's write it out. X minus 3, right, multiplied by itself 3 times. Now, we can only multiply 2 things at a time, and it looks like we've already done that. So some of our work is done for us here. So watch what I'm going to do. I'm going to say, okay, let's say that I'm multiplying these 2 first. I can just take the result of my previous problem and put that in there in place of that. X minus 3. And so open parentheses, right, because it's multiplication still. This is going to be x squared minus 6x plus 9. Okay, if you hadn't have just done it, you would have to go ahead and multiply it out, do the work. So now this looks familiar. Now we get to set this up as x distributed into the trinomial, and then minus 3 gets distributed into the trinomial. Keep some room there. Okay, let's go ahead and distribute and then combine like terms. Okay, let me make a little room here. Let me go ahead and get this out of the way for now. Okay, so now we'll distribute the first one. We'll have x cubed minus 6x squared plus 9x. And now we're distributing a negative 3 into the trinomial. So we'll have minus 3x squared. Now what? Negative times a negative, we have positive 18x. Watch your signs. And minus 27. Okay, so now we have to combine like terms. This is the only cubed term here. So that'll be brought down. X cubed. Now we have x squared terms here. Negative 6 minus 3. So minus 9x squared. For x terms, we have 9 and 18, which are what? That would be 27 plus 27. X, and our constant term of minus 27. Okay, good job. This is it. We're done. Okay, so the next problem I want to look at is here. Okay, and this is actually number 2 in this little problem set. So there's number 1, and I'll leave number 1 showing you in case that's one that you'd like to keep. Trinomial in this case, or polynomial, it doesn't matter if it has 5 terms, you're going to do the same thing. However many terms you have in the numerator, that's how many new fractions you're going to split this problem into. So we have 3 in this case. So what I'm going to do is draw 3 fraction bars, 1, 2, and 3. And whatever operation is between those terms there, I have one subtraction and one is addition. I'm going to put that between my fraction bars. So it'll take care of itself after I'm done. And what you're going to do here is you're going to take that denominator, the 4u to the 6 v squared here, and that's going to be the denominator in each fraction. So 4u to the 6 v squared gets put into each of the denominators of the fractions. And now what you're going to put into the numerators would be each term. So 12u squared v to the 8th will be my first numerator. Okay, and then 16u to the 6th v cubed. Remember, the subtraction is between the fraction bars. Of course, last we're going to have 4u to the 4th v to the 4th. Now we're going to take this one fraction at a time. Okay, so first we're going to look at this first fraction and go ahead and do our cancellations. Okay, of course 12 divided by 4 is going to give me 3. So you could also you could say 4 into itself once into 12 3 times. Okay, let me make my pen a little thinner. Yeah, that'll be better. And then the u squared, notice that 2 as the exponent, compare it to the 6 down there in the denominator. Okay, the 2 is smaller than the 6, so notice that we'll go in this direction. Let me write this out. I'm going to take this out over here. Okay, if I have a u squared over a u to the 6th, the smaller exponent cancels, okay, it becomes 1, and it actually subtracts that many off of the larger exponent, wherever that is, and that's where you're going to end up with your u to whatever power. So in this case, we'll have u to the 4th power in our denominator. So you can handle your variable cancellations like that. So we'll subtract 2 from the 6. See? Now v squared will cancel, and it'll take 2 off of the 8. Okay, let's rewrite what we have left. Okay, we're going to have a numerator of 3 and then v to the 6th power, and the denominator u to the 4th power. Okay, and what we're going to do is put our subtraction, right, carry that down, and let's go on and cancel from the second fraction. Okay, so you can carry on with that. Similarly, let's fast forward a little bit. So here's my solution. Okay, if you did it correctly, you would have 3v to the 6th power over u to the 4th power, okay, minus 4v plus v squared over u squared. And that is your solution. Okay, so here are a few notes to kind of keep in mind when you're dealing with negative exponents. Okay, what we need to remember would be these items. Okay, we cannot carry out an exponent until it is positive. Okay, so when you still have negative exponents in your problem, it's also not fully simplified. Okay, so when we start a problem, it's got negative exponents. All right, you have to make it positive before you can carry it out. I know the word positive is kind of funny looking. But remember, make the exponent positive before you carry it out. In other words, look what I have here in red. I have 2 to the negative 2. Okay, so this is not equal to 4. You can't just say this is 2 times 2. Okay, what you must do is this. Here's the correct thing to do. Okay, 2 to the negative 2. You see this, and you remember that you can write this over 1. Right, it's a fraction, right? You can write that. Right, you can kind of do this deal right here. Whoops. Okay, you can, okay, you can go over 1, right? Okay, so then you write it 1 over 2 to the positive 2. So it goes to the denominator in order for the exponent to be positive. Then you can carry it out. Once that exponent is positive, go for it. Multiply 2 times itself, right? And then you have your answer of 1/4. So this is the correct thing. This is what is the right way. Okay. Okay. All right. So you want to never leave negative exponents in your final answer. Always double check. Make sure you didn't forget any cancellations or any negative exponents that you need to invert to make them positive. And finally, this rule where we can raise factors inside parentheses to a power, and then we distribute this exponent into the parentheses, right? Each factor gets raised to that power. By the way, there's a fraction rule that's very similar to this. If I have a over b to the nth power, remember that the numerator and the denominator both get raised to that power individually. Okay, but note this problem, this rule that I have here, this what I have, I'm kind of circling it, that only works if there's multiplication inside those parentheses on that left side here, right here. Okay, so that doesn't work if you have okay, where did my parentheses go? That does not work if there is addition. Okay, so watch, let me write the bad one. Okay, kind of like I did up top. Okay, so here, this is what not to do. So don't do this. If you have, say, the sum of two numbers, and I have it raised to the nth power, what this is not a to the n plus b to the n. That would be bad, okay? That's no points, right? This is completely wrong. So this is wrong, all right? We don't want to do that. Okay, when you have a binomial raised to, let's say, whatever, the nth power is fine, a plus b to the nth power, what are you going to do? You're going to multiply a plus b times itself, n times. That's what you do. You do what you would do if you had 2 to the nth power. 2 times 2 times 2, you're going to have it n times. Okay? Remember, binomials are just, it is a number. You treat it as though you would treat a y or an x. So, you know, keep that in mind. All right, so let's go on to the next example. Okay, so using the information we were just talking about. So we have this -2 on the outside of the parentheses. And inside we have a very much unsimplified fraction. There are a couple ways we could approach this problem. Remember that with these type of problems with the exponents, there's usually going to be a couple of directions you can take when you're simplifying these. So I'm going to just do the one I think is just kind of, I guess, the most efficient way of doing it. Okay, what I'm going to do here is I'm going to rewrite it and give myself some room to do the cancellations. Okay, so, but I'm going to take care of the numerical part first. So 7 into itself and into 21 3 times. Okay, and that makes things a lot simpler right there. So of course I'm going to bring down that outside parenthesis of with the -2 exponent. Okay, so let me go ahead and just write what I'm just going to write instead of talking for a sec. So I'm going to write this out. When you're writing, give yourself some room between your variables, so you can cancel and keep track. Okay. All right, and then outside of the parentheses you have a -2. Okay, so here we go. We had a problem earlier where we saw that when you have the same base instead of fraction, the smaller exponent will cancel that many off of the larger exponent, right? And wherever it lands, wherever the larger exponent is, that's where your new simplified exponential form will end up. So this one ends up in the denominator, the x's. So here is y to the first power. This cancels itself, and it cancels 1 from this 9. Okay, z's cancel. It cancels 1 from the bottom z as well. Okay, so let's go ahead and rewrite everything. Look at our parentheses are getting a little closer. That's cool. So the numerator is 1, right? Everything's gone from there. Now we have x to the, what? 1, right? First power. You don't have to write that though. It's understood. We have y to the what? 8. If you got the 8th power, you're right. And z to the 2nd power. Okay. So now we're going to work on that -2 exponent. So in order to carry it out, in order to be able to bring it into each factor, I need it to be positive. Okay, so remember, what is your rule for the exponents with the negative exponent? Let's take a look. Well, the most basic one we've learned is this. If I have a to the -1, that means reciprocate, right? Take the reciprocal of whatever number. And so we'd have 1 over a to the +1, right? Okay, another thing, if we have a fraction, okay, let's say if we have a over b to the -n, okay, this would be the same as saying b over a to the +n, and then we have b to the n over a to the n. Okay, so this is a nice little all-around rule, this last little line I wrote here. You might want to write that down and hold on to it, because you can use this in any direction. Any of these rules, you can use them in any direction you need to simplify to get to the end. Let's go back up to our problem now. Okay, so now I'm going to take this negative from the 2, and I'm going to actually carry out only the negative part of the exponent. Okay, so I'm going to say reciprocate, right? I'm going to have x y to the 8th z squared, and it'll become like over 1, see? And then I'll have a +2. See what I'm doing there? Okay, and so you don't have to write the plus in front of the 2, but I'm doing that just to illustrate for you. So now I can carry out. Now I can bring that 2 in to the parentheses, to each factor, right? So let's do that. So now x will be squared, and I'm going to write this out, okay, just to make it official for you so you can understand what's going on. Y to the 8th will get squared, okay, and then z squared will be squared, okay. So now let's go ahead and take each of those factors and let's raise a power to a power, or just bring it down if it has nothing else to do with it. So now y to the 8th squared is going to be y to the 16th, right? When I raise a power to a power, I multiply. And finally z to the 4th power. This is my answer. Okie dokie. I'm curious to know if you guys did this a different way. If you took a different direction, you are welcome to get in touch with me and let me know. I can show you an alternative way. I may put that in the view office. I'll put an alternative solution. That's what I'll do. Okay. So we're going to move on to some geometry, some area and volume type of problems next. Okay, so the perimeter of this rectangle shown in the picture, the purple one here, is 104 inches. Perimeter. Remember, what is the perimeter? Perimeter is going to be the distance around an object. Okay? So, or it could be the sum of all the sides. Okay? For a rectangle, we can write this. Okay, let me kind of separate this out. For a rectangle, so I'm going to write perimeter, and I'll put just rectangle kind of abbreviated as a subscript. Okay? We'll have what? A length plus another length plus a width plus another width, right? So this is why you often see 2 lengths plus 2 widths as the perimeter of our rectangle. Okay, and so we can just put P for now. We know we're dealing with a rectangle. Okay, here we go. So we're asked to find first the value of x. Okay, so now it really doesn't matter which one you label, length and width, it's fine. Okay, so we'll let we'll let the width be 2x minus 1, and we'll let length be 4x plus 3. Okay, and so we'll just go ahead and plug what we know in. You plug in the things that you have information for. So in other words, what do we know from this formula? What information do we have? Okay, so we're told that the perimeter is 104 inches, right? We're told that the width is equal to 2x minus 1, and I'm on the right over there writing, and of course inches. We're told that the length is 4x plus 3 inches. Okay, and so we can go ahead and just plug everything in. So everything unknown in that formula is now known. And we just need to plug in. 104 is equal to 2 times the length. Now look at what we can do. We can write 2 times the 4 in the front, and that'll take care of it, the whole thing of length. Okay, x plus 3 plus, and then we have 2, and then write your width, the 2x minus 1. Okay, now just kind of clean this thing up, simplify it, and solve for x. So that's how we find x. Okay, so I'm going to begin by multiplying first these front numbers, the 2 times 4 and the 2 times 2. Okay, so we're cleaning that up before we go ahead and distribute. So bit by bit, take things, one step at a time. Keep organization, and you guys will have a lot less error when you are getting your scores back. Okay. All right. So what we're going to do now is we need to get the parentheses out of the scenario. We need to distribute the 8 and then the 4 into their respective parentheses there. So we'll distribute and then we'll combine like terms. So I'll begin by, let's distribute 8. So 8 times x, then 8 times 3. So what do we have there? We'll have, let me bring down the 104. A lot of traffic outside right now. Sorry about that. So 8x plus 24. Okay, and then we'll distribute the 4 into x minus 1. Here we go. Oh. All right. 4x, and 4 times negative 1 is minus 4. Now, remember I just said, every time you distribute, you want to combine like terms. And you'll hear me repeat that a lot at this point in any class I teach. So, let's combine those like terms. Let me make some room. Hello, get out of here. Okay, here we go. Combine like terms. We have 104 is equal to, now what, 12x and plus 20. Let's go ahead and subtract the 20 from both sides. And we'll have what? 84? Good. Then what? Divide by 12 on both sides. And we'll go ahead and write our solution of x is equal to 7. Okay? So we got A. That's part A. And we'll go ahead and bring our answer back up. So we said that x was what? 7. Okay. And so all this here was part A. Okay. So now we want to find the area of the rectangle. See, now we can go ahead and find the width and the length. Let's go ahead and find and plug in 7 for x and get the actual value of our width. So 2, and then we have 7 minus 1 in parentheses. Inches, of course. So now we have what? 2 times 6, or what? 12 inches for our width. The length would be what? 4. Put in a 7 plus 3. What is that? 40. Actually, 40 inches. And so how do we find the area? The area of a rectangle is what? Let me write that one in red too. So the area of a rectangle we know is, okay, I'm going to write this right here. Area is length times width. Very simple little formula. Okay. So let's go for it. So the area of the rectangle above would be 12 times 40. And notice it's 12 inches times 40 inches. So you have inches squared. Okay. So what do we have? 480. Square inches. And there's your answer for B. Okay? Okay, so Roger has this rectangle and its area is 3x squared plus 9x. And its length is 3x. What is the width? Well, we just learned about dividing polynomials, okay? And we actually had an example earlier with it was a trinomial divided by a monomial. In this case, we would do binomial divided by a monomial. In other words, if the area is equal to length times width, right? And we're asked to find the width, how would we solve for width? We would divide by length, right? Well, okay, what's going on here? Then we have the width would be equal to the area times, divided by the length. So here's our area, and here is our length, right? We know area, 3x squared plus 9x, and we know that the length is 3x. So let's fill that in. We're going to just go ahead and tack it onto this. Okay, so equal 3x squared plus 9x divided by 3x. So we only need to simplify this. And earlier I said that for each term in our numerator, they're going to separate into that many separate fractions. And in between fractions, we're going to put whatever operations were in the numerator as well. So let's go ahead and separate out and simplify. Our first fraction will be the first term divided by 3x. Put the plus sign there, and then the second term, 9x, divided by 3x. Same denominator all down the line, okay? Now, one fraction at a time. So all we can handle is just reduce and do what we can do. 3 goes in itself once. Okay, this single x in the denominator will cancel 1 from the 2 above, right? And here we have 3 into itself once, into 9 3 times, and both x's go, okay? So what's left over? Let's take a look. We have just the x to the first power, right? 2 minus 1. So we have x plus what's left is only a 3 for the second term. So x plus 3. Hopefully this is what you got when you tried this problem. Okay, let's go on to the next one. Okay. Okay, find the volume of this box. Here we go. So what is volume of a box shape? A volume of this shape here, okay? What is the area of just one large side, one of the floor side of it? Area was length times width, right? Area is length times width. And what volume does, it just adds one more dimension to the area. So we, instead of just length and width, we also have a height, right? So volume will be length times width times height. It's 3D, 3 dimensions. Okay? So that's kind of neat. I mean, it's good to know area of a square, area of a volume of a cube or rectangular cube, rectangular object. Okay, so here we go. So we have length as 3x plus 2. We have width 2x plus 5. And we have the height x minus 4. Simple. And so what do we do for volume? We're just going to multiply these guys together. So volume of this object will be these 3 binomials multiplied. 3x plus 2 times 2x plus 5 times x minus 4. Now remember, you can only multiply 2 of these things at a time. So any 2, you can pick whatever 2 you like the best, okay? It's up to you. So I like to pick, when I do this is just my choice. You can do this however you want to. Remember, we talked about that too earlier. There's usually more than one way to do a lot of these problems, okay? What I'm going to do is multiply the second 2 first, because I prefer to distribute a binomial into a trinomial for some reason. It's just my preference. You guys might like the other way around. It's okay. Okay, the more you practice, you'll know what you like better. You guys will know you might not even know. You might just need to try a few of these before you figure out how you want to approach it from now on. So that would be what you're needing to do first. So, okay, I'm going to bring down the 3x plus 2. Okay, remember to bring down parts you're not using yet. And in a set of parentheses, I'm going to write the product of these two binomials. Which you can do as well. Now, we can come on the side and FOIL if you want to. I'll take it in a gray. So what I'll do is I'll come out right here. Let's see. Okay, so look, I'm going to make a thought bubble here. That's not really a thought bubble looking at all. But look, I'm going to take that here. I'm going to write 2x plus 5, x minus 4. FOIL, right? First, outer, inner, last. First is 2x squared. Okay. Outer would be what? Negative 8 squared. X, excuse me, negative 8x. Inner is plus 5x. And last, minus 20. Okay, of course, go over your work again. We have what? The 2x squared minus 8x plus 5x minus 20. And then combine the middle terms, negative 8x and 5x. So 2x squared minus 3x, right? That's these two guys. Minus 20. So this is the trinomial you take back in place of the multiplication there. Okay, so let's bring that in. Let me darken my cursor up a little bit so I can see where my pen is. Okay, that's better. 2x squared minus 3x minus 20. So now I have binomial times trinomial. Okay, so let's take that one and run with it. Alright, so we're going to take each of these terms in the binomial in the beginning. So we'll take 3x and it will be distributed into the whole trinomial. So let me kind of highlight that. Let's see. That's good enough. I'm highlighting this because this is what I'm going to have to write. This is what we're distributing into. Okay. Let's make some room. And actually I want to make more room. Definitely a lot more room. Okay. Alright. That's not in this video. That's foreshadowing, I guess. I have foreshadowing in my videos. Look at that. In a math video. What do you know? Actually, it's going to come out. Okay. So, let's go ahead and we'll have first the 3x. That gets set up being distributed into the trinomial that we just wrote. That's highlighted. It is highlighted. And now we have the plus 2. See that second term there in our multiplier. Now that gets set up as being distributed as well into our trinomial. Okay. Alright. So again, take it one at a time, okay? Don't look at this whole thing and get overwhelmed. Just take it one at a time. If you need to take deep breaths while you do this, go for it. We can do this. 3x times 2x squared. 6x cubed. 3x times negative 3x is what? Negative or minus 9. X times x is x squared. Watch those exponents and signs. That's going to be the biggest thing. Just watch your sign rules and make sure you're adding your exponents correctly. Or I should say using the correct exponent rule. 3x times minus 20, right? So minus 60x. Notice because I'm keeping everything in descending order, right? X squared, x to the 1, x to the 0 is the constant. Because I'm keeping everything in a good order, as I multiply, look at how nice I've got my 3, my 2, 1. My countdown, my descending order will naturally start to show me a pattern. And as you practice these, you'll actually it'll be easier to pick out, you know, what to combine and just different patterns. It'll just really help you a lot. Alright, so now 2 times 2x squared is what? Plus 4x squared. Now watch what's going to happen. We're going to have like a little pattern that's going to happen here. This will also count down. 2 times negative 3x is what? Minus 6x. And then 2 times negative 20 minus 40. So let's go ahead and combine like terms and we'll be done. 6x cubed, we have what? X squared terms here. So negative 9 plus 4 minus 5x squared. Okay, so we got those. Now the x terms, negative 60 and minus 6. So minus 66x are done. And then minus 40. Look at that. Just like that, we're done. How do you like it? In descending order. How was that? That was easy, wasn't it? Not bad, because we kept a good organization on our way down from each step. Hey, you guys, y'all have a great day. Get in touch with me. Come visit me in the virtual office. And I'm happy to help you guys if you need it. Talk to you soon. Bye.